Hello and welcome to this tutorial on setting up our dep node. If you remember where we left off with our previous tutorial, we had just set up our user setup.py to point at our rigging tools folder. And now we are essentially going to start building within that folder that we're pointing at all of the different modules that we need to make our nodal setup. So let's close this user setup. Okay, I head over to our main, where if you remember we had a test in there saying hello world. For the main, essentially what I use this for is to open up a window. So I use a main window, and then I can just open that up from my toolbar for the window tools that are access all of my API within my rigging tool system. But we don't need that, and we're not going to really focus on that here. We're focusing more on our own API. So let's move on with this. And just for reference, during these series of tutorials, I may decide to fast forward on the code writing or just copy and paste it in, because I'm very aware that this could probably go into the hours, just me writing out code going here. So I'm going to try and fast forward through those bits, speak when needed, and then you can obviously pause to copy the code back in your own time. But obviously, whenever I feel that there's a need for me to interject or to explain something, then I will just stop and explain that before I maybe write out the next section of code. Okay, one thing you might have noticed here is that I've slightly updated the doc string. So I put a little bit more information in it, and going forward, although we're not going to be talking about doc strings at the minute, I may come back and add that during these series of tutorials, but I'm a bit of a time limit at the minute. I want to try and make sure I get these out before the summer, because otherwise I've been making these for months and months, and it has taken me a long time, obviously, just to find any time around. I've got one child and one on the way, and then I'm working a full-time job. It is very difficult to obviously find time to do these, but obviously I'd love to get this information out there for all of you amazing people. So yeah, I'm going to probably add things then a bit more fluidly in the future so that I can come back to them, but not try and just do everything at once, because obviously as developers, we do like to do that. But, you know, like I said, we need to prototype soon, get things out, get them done, and then increment and improve on them. So I'm going to try and use that same methodology with my process here. Okay, but let's have a look at what folders and what modules we need to set up. Let's firstly go into our modules folder here, and we're going to select new and Python package. We're going to call this Python package utils. Okay, and you'll see that is automatically added in the init. We're going to add another one called nodal. And within nodal, we are then going to add one more, actually two more probably. We are going to add one called base, and one more within nodal called tests. Now, actually, I shouldn't have done that there. We're going to be doing a tests video after this, but we'll just create everything as we need at the moment. Okay, so, okay, we've got our new 3 modules set up here. Okay, or 3 file Python directories, I should say. And within these, we're going to add some modules. So within utils, we are going to add a Python file called path. And within utils again, we are going to add another one called open my API. Okay, we are going to start by creating our submodules that we are going to be calling and using. But okay, let's go ahead. Actually, even then, actually, no, sorry, I'll create all the files that we need. Within our base, let's create a new Python folder, and we're going to call this dep node. So dep_node. And that stands for dependency node. So if you just put author, followed by your name, your company, if you have one. So again, doc strings should be nice and simple. So when we're calling modules, we can get a full readout of everything that's going on. I'd say that there's more information that you can even put there when appending or when updating these. You can always put maybe appended by. And then you could always put the name of that person so that when something's created, you know you have a few people that you can then go and talk to. Like I said before, this information will be useful and put into you when you are updating a file or a Python file that has maybe 300 or 400 lines of code. There's a lot of cross-module dependency, and you need to know what is going on and maybe get a bit more context. But again, that is why we're going to try and write good doc strings as we go through here to make everything obvious. So now let's make a mistake actually first. We are going to call one function generate repr string. And this is going to accept a class. Again, do not put class because that is a keyword. So in Python, so you will be writing over it. So don't do that. So just call it class. Can't write. You can't use variables or assign function names, class names to things that are called class. You can't call a class class. That would obviously then just write over the class functionality. Okay, but we've got our name, and what we're going to do here is quite simply return. Let's do a little bit of string formatting. We're going to return our class that is passed through. Sorry, here we go. And how do we need to do this? Because this is a repr, so we need to show how a functionality is called. So we're going to try and put everything in that we need to show somebody how this command was called. I think that does it there, because then we'd have our class name, and then we'd have the node that was passed to our dependency node. So now we need to do dot format. And again, like we spoke about with f strings, I do prefer f strings and I would much rather use them. But like I also said, we're using a system that is going to be back compatible to Python 2.7. So Python 2.7 doesn't have f strings, so we can't use f strings in here. But if you know that your system or that your company is only using Maya 2022, Maya 2023, then hey, fine, use f strings. That's much better, more readable, and will make you happier than it will me, because I still have to use these annoying formats, which, you know, first world annoying, but they are just not as nice to read or to write as we were talking about with f strings. So class equals class, which will be a string that we're passing through, and then node will equal. We want this to essentially be the root name. We're going to have another function in a moment that we will pass that will be called root name. But okay, let's to start with, let's look at a few things. Okay, so we've got a little squiggly underline under here. What does this mean? So pep8, okay, and then it's giving us the pep documentation point, expected 2 blank lines before. So after our documentation, pep says that you should have 2 blank lines, okay, which is for readability. And yes, I'm very much on board with that. So you see, it's reformatted our document. It has given us the correct formatting, and it has made sure that we have much better written code. But now, we've got another problem in that we've got an unresolved reference called root name. And okay, well, let's see what it does. Let's create that. Okay, cool. It's given us this root name. That's awesome. Okay, brilliant. So that is something that we can make in a minute. And then, yeah, it's already figured out as well that we want to call it, that it's going to take a name. So that is perfect. Okay, so we've got our squiggly line again. So it must, let's see what it says. Okay, expected 2 blank lines. So again, we want 2 blank lines before every function. So we're learning essentially what proper pep style guidelines say. But now let's create doc strings. So we're going to just highlight def here. You'll see this little pop-up light bulb come up, and we're going to go insert string. Okay, we don't want to actually do it with that setting though. But okay, let's just insert that for the minute. Okay, so you see this is actually using, I think this would be from Sphinx, maybe naming, I can't remember fully, but we're going to use the PyDocs essentially just because, well, in the future, when I come back and write that tutorial, if we use all the same convention with PyDocs, it'll make everything much easier. Okay, so what we're going to do here, we're going to say, well, this generates a string representation for the repr dunder method. Okay, as we talked about within our Python class, tutorial, within our Python course, crash course. So let's get writing these docs. Let's have a look at our args here. Again, this might seem like a lot, and I wouldn't always recommend writing this many docs, but depending on the size of your company and the amount of people using your code, this might be quite useful, because this is quite a useful method, and it will be used probably in all of your classes going forward whenever you need to use the repr dunder method. So as we've talked about here, this generates the string representation for the repr, or the representation dunder method, which gives us a class representation of how to create our method, or how we created our class-based object. So the args that this takes is class string, which is a string type, sorry, and which will be passed with you giving essentially your class and then the double underscore dunder method name of the class, and then with the name of the node that was used, which is also a string. We are then saying what this returns, which will be a string, which is a representation of the special method, or the representation of the repr method. Okay, so we're going to use this when we come back to our dep node shortly. But this will then, and we then give an example of how to use this, which we imagine in our docs and our HTML docs will be incredibly useful. We give an example. So repr. So we could essentially say when within the repr method, we just return, generate using this method, or using this function, we will essentially generate, and then we will say, well, self.class name, and then the full path of our node, which we will then come through, or it could be just node, but you see, we'll always get the root name anyway. So we'll always safely use this method, or this new function down here, sorry, to get this new name. Okay, we'll go on and make that now. But again, essentially, this seems pretty straightforward. And then what we can do is just copy out this this text here and use this for all of our other items going forward, along with, again, the text at the top. So we're already going to be getting quicker going through forward on everything. So let's move on to our root name. So as we said, we're going to be using this to strip out the grouping information from a given path. So within Maya, you essentially, if you have 7 groups, and then 7 groups down, you have a joint. If you get the full path, you're going to get all of those items. But we don't necessarily want all of those, but we do want a way to quickly and easily just get the root name of that object, and that is what this function here will do. So let's just quickly go, let's give it some functionality. There we go. So now we've got our functionality, and we're saying, well, if there is not name, let's say name is either an empty string, because remember, an empty string, this would come up through as none. Maybe they've accidentally passed a 0, and that's also none. Or maybe there is literally a none type that has been passed through. Okay, then that all needs to that needs to be returned. Okay, but if there is something there, then we can quite quickly go, actually split this. Okay, remove all of the items that are separating from our root name, and then pick the last one. So we're returning a list, splitting by all of these pipes, and then returning the last one within our string. Okay, let's write our docs for this. So let's copy these docs. We'll go down. Okay, and then let's update these docs then. Okay, so let's have a little look. Okay, well, usefully as well, we've got a spelling mistake here, but let's have a quick look. Replace with information. Yep, already knows that we've just got a silly little typo. Let's replace that. It's great. Literally is kind of why I love PyCharm, along with macros and lots of other things. Definitely look up macros if you can. Another really good reason. I'll probably mention that before I forget to mention it again. But here we go with our root name functionality. So what we're saying here is this strips out grouping information from a given full path. Let's have a look at the example first. So yeah, this is the full path of an object. We've got a base group, subgroup. Let's imagine it's for some reason got a namespace, and geosphere. Well, we're saying we want the root name. We don't want to append that anyway. So we are literally just splitting out all of the pipes. We are removing these, getting a list of these 3 items, so separating using the pipes. And that will then give us the last item in that list, which is namespace sphere geo. And now we also want to add two more functions. Again, all of this is just really for string appendation, so within path, but obviously you can add a lot more within this function, within this method, and add lots of functions that do lots of string appendation, because obviously when you're writing pipeline methods, you want to be able to update strings, add versioning to them. You want to change the extensions on different files. So yeah, this is a module that will get very big over time, and I've split it out into several sections on my pipeline, but we'll just use the ones that we need as we go through this series of tutorials. Okay, let's write our next one here, which is going to be called base name. And you see, we've just copied this whole method, obviously, for speed. But let's see what it says here. So redeclared, root name defined. Okay, so great. It's telling us we've actually already got something called this. So that's pretty useful. We can just rename this base. Okay, oh, my computer's starting to lag a little bit with all of the windows open, and I'm trying to record the screen. Let's hope we don't get a crash. Okay, so now we've got base name with string, so we need to reformat because we're, again, not two spaces away. And within base name, we're going to do essentially the same as above. So we're going to split the name, but we're going to get the base name, which is now not including our namespace. So we want to now try and take care of our namespace. So let's split again. Now within the split, we're going to remove the namespace by splitting it into two different lists, and then we'll pick into a list with two items, and then we'll pick the last item, which will be after the namespace. Okay, perfect. Now let's write out the information for what this function is doing. Okay, so here we go. We have essentially appended our docs. We've given the example, which is now each item essentially with a namespace. But with this, obviously, we are then removing the pipes, and we are then removing the namespace and just getting the final item, which is sphere geo. So we've got our example, which is showing the variable. We are showing the function, and then we are showing the output. Very useful. Everything. This is normally the first thing that I look at if I'm going through docs. Okay, and then we have got the returns. Okay, so we are going through base name. We are passing it a name with the argument name, which is a string. This contains the name containing group information, which returns the name without grouping or namespace information. Okay, perfect. And then our last function that we are going to need is a namespace. Again, all of these are going to be used within our dep node. Okay, there we go. So we'll see I've appended this to actually return an empty string, because if we don't find one, what we actually want to return is, well, nothing. We want to say, well, there is no empty string in here. And we could keep this either an empty string, or we could go none. But for the moment, we will just leave this as an empty string. Okay, so this is a function that will return the namespace if any exists, which is why this is appended. Okay, our args that it takes are the name, which is a string, which is information. This is a string containing namespace information. We have then also got, and then we will return a string of that namespace information. And then an example is, so imagine we've got all the items that have been referenced into our scene, and we've got namespace with each item. Okay, and then the last item is a sphere geo. What we're going to do is we're going to get the last item here, the root name, which provides us with the namespace and the last item, but then it right splits from the end, and it then gives us our first item before the split. Okay, so we split this into a list of two items with namespace and sphere geo, and we are then getting the first item within that list, the first indexed item. Okay, perfect. So that is everything that we need for the path module. This is all the information we've got, which, And we will test that usage when we are later on in our tutorial after this. But now we need to go and look at OpenMaya. So this is a nice new module that we need to look at for ourselves, which we haven't actually explained or talked about yet. Okay, let's go back to path. We're going to now steal our doc header, keep all the information there, and we're going to now start writing in OpenMaya, or OpenMaya API module, which essentially we only need to write a few bits for this, and then we'll have them for all of our other modules. We won't need to come back to these. I'd actually say this is probably one of the less interesting parts, just because this gives us pretty much a way of converting Maya nodes into various Maya API objects, like M objects, M DAG paths, and dependency nodes. These functions are really useful when working with the Maya Python API, and they perform various operations for the underlying nodes and for underlying Maya Python, Maya API functionalities, like getting the base path, getting the full, making sure that you don't have two objects that are the same thing. Mainly what we are going to be using this for is for checking our objects and getting the full paths of our objects, and then using that to essentially check them. So let's put that information in. Let's just give a little brief bit of information there. I would recommend looking a little bit more into this after these tutorials, a little bit more about the Maya API. It's quite useful and quite powerful, but I like to abstract it essentially because I don't think it's as well written or as understandable as it possibly could be. But okay, let's do the imports that we need. Firstly, from Maya, import OpenMaya, and you'll see amazingly it's already it's already been prompted for us. That's great. And now we're highlighted, which I'm assuming because we're not using it. Yeah, unused import. That's great. This is very useful when you have very big files to check through them and say, well, are they being used? When are they being used? Okay, so let's write our function here then. Okay, and what we want to do here is we want to have an object which is m object, and you'll see again we have a little red underline here, which because we don't have this. No, this is actually saying, oh, okay, so it's actually giving us a PyML, but we're not using PyML. We're going to stay away from that. We're going to make this our own functionality, which I was hoping it would prompt us for, just so we could quickly create our own functionality. Okay, great. So we have our functionality there. All right, so let's also return the object that we need, which is OpenMaya dot mfn dependency node. That's the one. Perfect. And then our object. Okay, perfect. All right. So we'll write these docs up in a second, but what we're looking at here is a function that will take a node as an input and convert it into an OpenMaya dependency object. It's similar to the previous functions or the other functions that we're going to talk about in this tutorial, and it uses the M object to obtain the OpenMaya M object, which is a representation of the node. It then creates the dependency node using the obtained object and returns it. So the obtained object we've got here and returns it. And we're going to go into more detail of what this will do for us in just a little bit. But now let's look at our next, let's have a look at our next function, which we started creating, which was toMObject. And in this one, we are going to write out selection list. We'll call this selection list. And this will equal OpenMaya dot m selection. Yes, there we go. Perfect. Okay, and that selection list dot add and then node, okay, that we pass through to it. Then we're going to create an object variable, which is now openMaya.mObject. We're going to go selection. Here we go. Selection list dot get dependent node 0 and object. And our object, and then from that we are going to return object. Okay, this is essentially converting a node into an OpenMaya object here. So we have a dependency node and we have an object. This one will probably be more useful when we are looking for namespaces, or paths of items. But at the moment, this function is essentially going to take a node as an input and convert it into a Maya object. And it does this by creating a Maya object selection list, adding the node to the selection list, and then retrieving the OpenMaya object using getDependentNode. Finally, it returns the obtained Maya object for us to use. So let's write out some doc strings for this. Let's go to path. Let's steal one of our doc strings. Okay, so here is our string information. We've got the dependency node, which converts a node. It converts any node we pass into an OpenMaya dependency node. We've got our mObject functionality, which converts any node into an OpenMaya, I should say, object, really. And then we'll see we return the string. Actually, no, this isn't a string. This is an object. So put that down as well. Okay, and then we have essentially finished off our documentation for this. And I hope that this is being well explained by myself. But again, this could be a whole series of tutorials in itself, so we'll kind of flash through this. So let's also add a few examples into our Maya API code. So we will see with the toDependency node function that if we passed a left-hand joint, we then use this function with passing its name. We could then print out that object with the name type, and it would give us an output of a joint. So it's giving us a few little useful features there, which I'd say was easier than going Maya dot object type open parentheses. It's already abstracting that, and then we can abstract that a little bit further by just doing object type, say within our code. So we're starting to abstract down, and again, we're only abstracting or needing to abstract once here to go into our code base, which is over in dependency node. And then we won't have to use this kind of methodology again, because I wouldn't say that these names are too readable, especially for onboarding new people. So, and then our example for our to object, to our Maya object, is as follows. Let's say that we passed an example with the name left-hand joint again. We created that as an object with a to object. Now, if we wanted to print the object full path name, which would essentially be in our code base full path, which will be when we've written it, we will get the full path of that joint. Let's say it's within base group, subgroup, and then left-hand joint. It'll give us that full path. So it'll always be very easy for us to access the exact location. For example, if you have multiple left-hand joints, which you shouldn't do, but you might accidentally have that. So you can then at least find out the location of an item. Okay, great. Let's move on over to our dependency node now. So let's start off by copying docs from the OpenMaya API, and we will then go into our dep node. Okay, we'll keep all the information the same. Okay, so in our docs, we've written our dep node functionality to deal with my base nodes with no object dependency. So this is more like a group item. This is not, say, a mesh item, which would have both the transform and then the mesh shape underneath, or maybe a NURBS curve where the mesh, where again you have the transform and then the NURBS curve shape. This is essentially an item, for example, maybe like a Maya node, like a multiply divide node, or a multi-double linear node. This will be for nodes and for items without dependency. So from Maya, import commands as M. So we're going to import our Maya commands library with the namespace of M. We also need to import from our utilities. So let's do that now. Okay, great. So got an initial problem, which we don't have two spaces right up here. Let's see, and optimize imports. No, we don't do that. Okay, it's going to only give us the option to optimize imports and remove all the imports that we're not using. But we obviously don't want to do that because we will be using these quite shortly. So now let us create our class dep node. Finally there. Okay, and then, oh, sorry, I should probably say, so to tab in, okay, or to move items in, we can just press tab. And then to move them back out, we just press shift tab. So we're going to take two arguments in here. And then just copy and V, and it'll copy the whole line if you just have your cursor in there. Okay, well, we've created our string now. Our doc string. So any developer that is now searching for information about what we've done here or what this class does will be able to look at the information and go, okay, well, this is a class-based way of calling information that we need to deal with Maya nodes that with no dependency. And there it takes a node, which can either take a node or a string, which takes either a ready-made base node or the name of one to create, and a node type, which is a string used for creating a specific type of node. And this is obviously going to be optional. I say obviously, it isn't obvious yet. It will be in a minute. Okay, let's go ahead and create our special method or our constructor for this class, which is our init. So let's space in and go def and underscore underscore. Let's see if we can get it quickly in the list. Init, there we go. All right, and now all we need to add here is our two options, which are node and node type. Okay, perfect. And within our constructor, what we are going to type is self._dep, which will be a variable which we are now signifying not to be used by anyone outside of the class. We will also create self.node, which will equal the node that we have just passed. So we will now create a function that will only run if we pass the node type. Okay, so this will be if node type and not self.exists. We're going to write this functionality in a bit. Kind of a chicken and egg situation for us, but we're going to go with the egg. So self.create and then node type, because we have already initiated a class-based variable which has got the node name. We've already passed that. So all we would need to do is pass essentially to our create functionality the node type. Let's give us a little bit of space down here. All right. And next we're going to create a few of our special dunder methods, which will again give us an extra bit of very cool functionality to work with. Let's create a little spacer just so we kind of the code makes it a little bit easier for us to look at. I do these little kind of spacers here. So we're kind of now saying, well, we've got our initiate. Now I'm going to do a little spacer, which isn't read by Python, so it doesn't really matter, but it'll maybe just help functionality for us, or sorry, readability. But okay, we need three dunder methods here. We need def underscore string. We need our def underscore wrapper. And we need our def double underscore equal to check if we have another method or another class that this is the same, essentially. Within string, if somebody asks for the string representation of this item, we are going to, as default for every item within the hierarchy, go for the full path. With this item, as if it's just a node like a multiply divide node, it won't really matter because it won't have a full path, but it will just give the name. But it doesn't really matter because every other item that does have a path will then give the path. Okay, so what we're saying here is full path equals self.fullPath. Need to go for self there. And if there is not a full path, then just return invalid object. Okay, if not, return full path. So now let's go for our wrapper. And luckily, we already have our method that we've made for this, our function. So we just need to go path. So that is our module dot generate wrapper from string. And now PyCharm is helpfully just giving us exactly what we the method that we need to put in. So now we can use another dunder method, which is the class itself. So this is a representation of our class, self.class, and then double underscore name, and says what it does on the tin, just the name of this class. So it will quite literally return depnode. And then as a second point for it, we are then going to return the full name. Sorry, the full path. Okay, for our object. So if somebody needs to recreate it, they get the name of the class and then the name of the object, or the full path of the object, to pass to that. And then we've got our wrapper. So you see, everything starts to kind of cascade and become easier and easier, even at this kind of low point where we haven't really got any code. We're starting to already get some ease back into our programming. So now we've already got our equality checker here, which has been filled in. We've already got a method to pass another item to it, which has been aptly named other. So we're going to run with that. And we're going to go, well, if is instance, we're going to work with other and self.class. So I'm doing self underscore class. Then return self, what am I doing? A self full path equals other full path, because we're checking here that these classes are the same. So if they're the same class, then what we can check is then if they have the same path. And if they have the same path, then they're basically just the same item. So we're checking if two class-based objects would be the same item, which would then check if we're wasting our breath when coding. And I think we've got all of the cases here. So we're saying, well, as we've already said, if an instance of this is a class, which is also our dependency node, if the classes are the same, and if their full paths are the same, then they are the same item. Or if what we're actually checking, if self.fullPath is actually the name of the full path that we've been passed, then again, the items are the same. So we're also checking if actually just a string is the same as the other item being passed to us, and if not just the name of the item is being passed. And if all of these don't pass to return true, then it's false. Then this item is not the same. Let's add another break. Copy that. Add that in. And let's add our first property. So this is we've got our property decorator here. This will essentially just be a property that defines the getter for our node. Okay, now let's create the setter. So here is our node setter. And this setter is for the node attribute. It sets the value of the node item, the attribute, and updates the underscore dep attribute accordingly. So this again is an attribute which we're not going to be getting we're not going to be using outside of the class, but we will be using it within the class. And if we see here, we're using I open my API and our dependency node, which we can see then if we click on the link, it takes us straight to the item that we wrote earlier and gives us an open my dependency node. Okay, let's go back to dep node. Let's not do that. Just keep everything nice and open at the minute. Let's move them in order of what we're using at the moment. Let's go this way. Okay, so we've got our dep node. So as we're saying, so we've got our dep node, which we are on set, we're default saying is none. And then we are setting our underscore node variable to string node. If node is not none, else then we will just set it to none. Okay, and we're saying, well, if there is not a string, if there is not a self.node and the object does not exist, then we'll return false. So we haven't been able to essentially set node. And that is what we will say there. But with our underscore dep, our kind of in-class dep variable, we are setting that to being a dependency node. Okay, now let's go on and we will probably use that right now. Okay, let's create a new function. I'm just going to call this dep, because this will be the way that dep is actually called from outside of the class if needed. We will return self._dep. Simple as that. Sorry, I forgot to say this is a property, isn't it? There we go. All right, it's kind of there by itself, but actually, well, no, it's not. Let's add a few more properties. We have got our path and full path, which will be, full path is mostly for our class hierarchy, but we will add it in here so that it is then inherited by all of our other classes going forward, like our DAG node or our joint node, for example, because then we can just get the full path of those items if needed. Okay, so property, let's go def, also path. And that's not right. It's self. Okay, and then we will say if self.dep return path. Sorry, self.path. Sorry, self. So we will say so we've got our property here, which then says, which is a path, which returns if there is a dep node, we'll return the dep name. So using our my dependency object, we'll return name. Now we have added our full path, which is again a property and another way of us accessing a path. So we are literally just saying self.path here. Now let's write a little check actually for, is this item referenced? So is is referenced. And here we will just return whether this item is referenced or not using a Maya check. So we will just pass the full path and then is node referenced. So if you go to your Maya docs and look up the Maya reference query, then you will be able to see this argument. So now we can check if we have a referenced node item that we are dealing with within our scenes. Okay, next, another one of the very important checks which is done, which I think is probably one of the most used items, I think, within this code base from my point of view, and it exists. Again, very much just an abstraction of the Maya object exists. So let's go with, okay, so essentially what we're saying here is if self full path and M object exists, then return true. So this essentially will give you a Boolean response, which we are then saying, well, if it's true, return true, false, false. We could also just go return that and just remove the rest of the need. But I feel like it's a little bit more readable with what we had, so we're going to just stick with that. Again, the only really dictator, the big dictator here is whether we think it's readable enough. Okay, let's move on to our next bit of code. Okay, so what we've got here is two new properties that will allow us just to check what type we've got. So as we saw within our dep, okay, with our dependency node, let's keep on just following back. We can go to a my dependency node. What we see here is that if we want to check the type, we can actually use this dependency node object, which is hijacking and going straight into the Maya API, to check what an item is by saying object type name. And that is giving us the object type, which would, for example, with that item be a joint. And that is exactly what we're doing there within our code. Within Maya coding convention, there's a lot of TYP and TYPE for type. So just so we make sure that we have both options there, because you'll end up writing both at some point and then wonder why TYP doesn't work and then end up saying, okay, well, might as well just put both if you use it enough. Okay, and there we go. So essentially, you see what we're doing here is, again, we're using our path module, and we're using the function from that base name. And this is going to be a property. So if we ever need to gather the name of our item, we're using the string, and then we're appending that with our string appendation within base name, which will then return us the name without namespaces that we need to use. And then this is also just another getter that we are using essentially. Let's call this one namespace. So we have the functionality, we might as well use it. Let's get the namespace if our item has a namespace and is referenced. So this property decorator defines the namespace attribute, and it returns this namespace of a node if there is one. Okay, perfect. We're moving on pretty quickly now using Maya commands. We just need a self and the name that is passed. And actually, we probably want to return self here, because we want to return the object, not the string. And if we use Maya commands, we'll actually return a string instead. So we'll do the utility function. Okay, we'll use this node to rename using Maya commands. We will rename our node. Okay, and then we will return self in case the user or the writer of the script is essentially expecting the object to be returned back. Okay, our next function will be to lock. Okay, so this is, again, if you're working in a team and you know that nodes you don't want to be deleted or changed by anyone opening up the rig scene, you can essentially lock various items within your scene. And that is using the Maya commands lock node, as you see there. So we need self.fullPath. And then the lock state, which we will set to being a state which is passed. So you can obviously pick that as a user. We'll set the default to true. And we don't need to return anything here. Okay, so now let's create another property though, which will essentially check whether our node is locked or not. We've got the ability to lock it, so we might as well now check if it is locked. And we will return lock node, but now we are going to essentially do a query instead. So let's do self.fullPath again. And we will go query equals true and lock. We want to get the lock state. Okay, it's worth going and checking the API for these. Now the last section, let's essentially delete our item if we want to in the scene. We are not going to use the dunder method. Because we want this to be more of a Maya-based delete. Okay, this method is essentially going to delete the node from the Maya scene, but we still might want to use the object to say, does this node exist? And say, if self exists, yes, no. Okay, give that information back to the user essentially. Okay, so what we have here is a method that essentially just deletes a node from our Maya scene. Now, we still want the class to be accessible, so we're not going to use the dunder delete method, which would delete our Python class as well, because we want to be able to say, does this item exist? And we want to be able to say sphere.exists still. But if we delete the class, we can't even do that check. So we're going to leave the class object alone for the moment. And now we're going to go ahead and create a node if needed. So this method creates a new node of the specific node type and assigns it to the node attribute. Okay, we also give the information back that if this item already exists, then we give the user back the information saying this node already exists, the name and the type of the object using our string formatting with the format string formatting option, because obviously f strings can't be used because that will not be back compatible to Python 2. If you are only using Python 3, then hey, go ahead. But also I'm using these 3 arrows just to help me within my command window see anything that has been output by rigging. And these kind of 3 arrows I'm kind of using for myself to say, actually, yeah, anything that is using these, I know it's spit out by my rigging pipeline. Okay, amazing. I think that's everything there, guys. Okay, brilliant work. And I look forward to seeing you on the next tutorial, where we are actually going to look at now testing all this methodology and seeing what works and doesn't work, and then fixing that.